Okay, so we're going to go over 10A, B, C, and D. So 10A reads solid iron 2 combines with oxygen gas. So we have iron, which is Fe, combines with oxygen gas. Oxygen gas is diatomic. This will be a synthesis reaction because I start with, looks like 2 elements. This will combine into, I know the iron is iron 2, so it'll be Fe plus 2 with oxygen gas, which is O minus 2, so it'll be FeO2. To balance this, the irons are balanced, and then the oxygens are balanced. Actually, I'm sorry, made a mistake. So if I could back up just really quickly, iron is plus 2, oxygen is minus 2. I know iron's plus 2 because it's iron 2. So it should be a 1-to-1. There should not be a 2 there. Sorry about that. And then if I want to balance it, it would be 2 FeO to 2 Fe. So now I have 2 oxygens on either side and 2 irons on either side. The next one is solid potassium iodide decomposes. So this is a decomposition reaction. These are decomposes. Solid potassium iodide, potassium is a K plus 1, iodide is I minus 1, so the Ki decomposes into its elemental form, which is potassium plus iodine. Remember, iodine is a diatomic. So this is what I call my skeleton equation. To balance it, it would look like this: 2 potassiums on each side and 2 iodines on each side. Letter C, it says a silver coin is dropped into a container of sulfuric acid. So a silver coin is Ag. Sulfuric acid is actually hydrogen with sulfate. Remember, sulfuric, IC-ic, replaces ATE. So at one point this was sulfate. Sulfate is SO4 minus 2. The hydrogen is H plus 1. So putting this together, it would be Ag plus H2SO4. This Ag is a potential cation, so it's going to replace the cation here, which is the hydrogen. So I have to determine if this reaction will go. If silver is higher than hydrogen, which it isn't. So if you look at the single displacement activity series, you'll notice silver is below hydrogen. Because silver is below hydrogen, it does not have enough energy to displace hydrogen, and so therefore there will be no reaction. This is a single replacement reaction because we have a single element that wants to replace another element in the compound. No reaction. And the last one is lithium sulfate and potassium phosphate mixed together. Lithium is Li plus 1, sulfate is SO4 negative 2, potassium is K plus 1, and then phosphate is PO4 negative 3. Alright, so let's put them together. So I have lithium sulfate, which is Li2SO4. I need 2 lithiums for every 1 sulfate, plus K3PO4. I need 3 potassiums for every 1 phosphate so that my charge is neutralized. So what I'm going to do is now pair lithium. So this is a double replacement, right? So what I'm going to do is I'm going to pair lithium with phosphate. So lithium is plus 1, phosphate is minus 3. So this is lithium 3 phosphate plus, I'm going to pair potassium with sulfate, K plus 1 with SO4 negative 2. So it'll be K2SO4. Okay. Alright. So at this point, I have a double replacement. But remember, with a single replacement or a double replacement, we have to figure out if this reaction is going to actually happen. So remember, there are 3 things that the products could be in order for this reaction to occur. One of it, they can be a gas, or you could produce water or ammonia, or one of them can be insoluble. Right now I can tell you one of the products will not be a gas because they have metals in the compound. The next one is, you will notice that the products here are neither water nor ammonia. Next, I'm going to check the solubility. This is actually pretty easy. The hint here is group 1 metals are always soluble. So it doesn't matter what they pair with, they're always going to be soluble. Lithium is a group 1, potassium is a group 1. Therefore, these both are soluble. I don't care about the anion, I just know the little trick that all group 1 metals are soluble. So since these are both aqueous, or soluble, it doesn't meet any of the requirements, therefore there's going to be no reaction. This reaction won't occur. Alright, hopefully that helps.